Okay, learning about an exponential equation. An exponential function looks like this. Y equals a times b to the x. And when you're looking at something like that, this is called the base. This is an exponent. And then this is actually detached from it because BEDMAS says you have to do this exponent, then multiply. So it's a coefficient multiplier. But do you know what I mean with BEDMAS? I'd have to do b to the x, get it, and then times it by a, right? It's separate. Okay, we're going to graph this one. So I need you to go into your calculator and give me your y equals screen. Get rid of anything you have in there. Deactivate a plot if you have that on. And I need you to go 10 to the x. Do you remember where the to the button is? It's that underneath the clear, that little hat button. And then just to reset my window, do you remember how to just reset it to the basic window? Zoom 6.
I did that a lot.
Yeah, just get it back to the normal. Okay, so if I trace, it goes to my y-intercept there, which is 0, 1. So I'm going to just sketch this graph down here. And then this is what it's looking like. Okay, it is never, ever, ever going to cross this or touch this axis down here. Okay, so I don't know if you've ever heard this word before. If it's never ever going to touch and it's going to just kind of like follow along, it's called asymptote. Yeah, you've heard that word before. Yeah, Hunter. You what? It wasn't in it? Okay.
I just got two.
Ah, there we go. Okay.
I'd like to, but
Okay. Let's go back to this, and we're going to write down the numbers that are actually on this curve. So can you go to the table? Second graph, so the table. So when I had a -3, are you guys at a 0.001? -2 is 0.01. I'm not getting. Okay, so you would go to here. So you can go to second table set, and then you can pick where you want to start at. So if you go -3 and then go second table, it'll start. Was yours at like really high?
Yeah, mine was at like 90.
Is yours like that too? Yeah. So there's this button called table set, so you can go second table set, and then you can tell your table where to start from. Like if I wanted to know the values of when x was 20, I can just go 20, enter, and the table would start from wherever I want, okay? Okay, do you know how these numbers are getting like that? So for instance, 10 to the 0 is, do you know what exponent 0 does? 1, right? If x was 1, 10 to the 1 is 10. Do you see where all these numbers are coming from? If x was 2, what is 10 squared? 100, right? So do you see why these numbers are like really, really, really increasing quickly? And then same here. Okay, they're also decreasing, 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 decreasing quickly. Okay, do you see that this value will never get 0 or negative? You're just going to get smaller and smaller and smaller and smaller and smaller, smaller, smaller.
Is that possible?
You can't get to 0
Why?
or negative. Because no matter what I do, 10 to the anything, like there's no way to get to 0. Yeah. Okay. Can you put those coordinates on that graph then? 0, 1, and 1, 10. All right, we are going to now graph this one. So y equals 2 times 5 to the x. So I put a times symbol between. So 2 times 5 to the x. And I'm going to graph it. I'm going to trace. So it's making the same shape. Okay, so I drew it again like that, and then there's an asymptote right at 0. It's never ever going to hit this axis. Okay, and if I push trace, I have a coordinate 0, 2. And if I do a 1, I get 1, 10.
Is that what it'll always be?
Nope. How come it turned out to be 10? Because what is 5 to the 1? 5, and then times 2, that's where you got to the 10. Okay, ready? Y equals bracket 1 divided by 2 to the x. That's our next one. Brackets, you got to put that in brackets or else it will go badly. So 1/2 Are you getting a different shape this time? The other way? Okay, push trace. I get 0, 1. And then push 1, enter. And you're getting 1, 0.5.
Why do we do that?
What's that?
Why do we do that?
Because 1/2 to the power of 1 is just 1/2. Okay, last one. Go ahead. So y equals 8 times brackets. This is what it should look like. 8 times brackets 1/4 to the x. Did yours look like that shape? And did you find me a coordinate here? 0, comma, 8, 1, comma, 2?
So that's how we find the other coordinate?
You can find any coordinate you want by just pushing any, like I could go -1, comma, and I would just go -1, enter, so -1, comma, 32, or whatever.
So for the specific thing, we just do 1 enter to,
Yeah, just to find a few points.
doesn't matter what points it is?
Okay, let's talk about some of the criteria here. So what are the x-intercepts? So where is it crossing this line? It doesn't, so guess what I'm going to write? None on all of them, right? None of them. There's that asymptote there, so none of them ever crossed.
What if it's not asymptote?
These will always make an asymptote.
Okay,
Yeah.
so in this unit, there'll always be asymptote.
Yeah, there'll always be an asymptote, yeah. Okay, y-intercept. So the first one had a y-intercept at 1. This was 2, this was 1, this was 8. Okay, does anybody have a rule that they would see about what the y-intercept would do? The y-intercept should be at 1. Here they weren't, and there's something that changed it. What was the thing that changed the 1? So why did this become 2 and why did this one become 8? Do you see where that comes from? Something to do with the coefficient. That is a 2, that's an 8. Is there a coefficient here?
No.
No, so it's 1. Is there a coefficient here? No, so it's 1. So the y-intercept would always be at 0, comma 1 unless multiplier. As soon as there's a multiplier, it changes that. End behavior. Okay, so F and G are doing the same thing. What quadrant to what quadrant is this doing? Anybody think about the quadrants? So which quadrant is this arrow in?
2.
2, 2, 1. So this one is going from quadrant 2 to 1 as it's increasing. Okay, then we have our H and our J are doing the same thing as each other. They're going from quadrant 2 to quadrant 1 also, but they are decreasing. Okay, so can anybody identify what's the same with F and G that make it increase versus why are H and J decreasing? So these two increasing, these two are decreasing. What's the comparable? Looking at the numbers. What makes something increase and decrease? Can anybody spot the difference? The base here is 10, the base here is 5, the base here is a half, and the base here is a quarter. So what should we say? If the base is bigger than 1, you're going to increase. If the base is less than 1, you're going to decrease. So base greater than 1, base less than 1. So that's what we know about the end behavior. So you're going to either increase or decrease. And I feel like the word that they use for decreasing is called decay. You decay.
It's like a body decaying.
Yes. Yeah. Decomposing. Okay. Domain. It's actually the same for every single one of these. What's the left to the right? What's the domain going to be? Negative infinity to positive infinity.
Will that always be the case?
Like, it is on any graph, but then when you apply it to a word problem, you have to look at the word problem part. So, like, if it's something with time, well, it's not just negative infinity to infinity now, right? And the range, always the same here. What's the lowest height? 0 to highest infinity. And what kind of bracket would I put on this 0? Round. Do you touch 0? Do you touch that line? No. So you never hit the height of 0, ever. You get really close to it, but you never touch it.
Wait. What? Oh, okay.
Okay. Now, I'm going to show you, there's this weird button called E, and it gets used in math. It's kind of like how we also use pi. Pi is really 3.14 da 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 da. Okay, there's this button called E in your calculator. Can you locate it? It is, there's your on button. You need to go 2 up, and you have to push second ln.
Oh. Gives you a line.
Okay, and then if I go e to the 1, the value of e is 2.7-ish.
How did you do that?
So again, I just went second ln,
Yeah.
and then it goes e to the,
Oh, not in
and then I just push 1 bracket. I'm just on my home screen. Is that why you're in your?
Yeah.
Yeah. Okay, so there we go. That's what the value of e is. So I'm going to go y equals e to the x. And I'm going to graph it. I knew that it was going to go increasing because e is 2 points. There's no coefficient, but it's more because the base was bigger than 1. Okay, so the value of e is 2.7-ish, so I'm going to increase. So it looks like that. What is the y-intercept?
What?
It's at 1 because there's no coefficient. So it just stayed there. Can you hit 1? And there we go, 2.7-ish. 1 comma 2.72.
I don't know where to put your quarter. Never mind, I understand.
Okay, ready to graph the next one? Y equals 9 times bracket 2/3 to the x. 9 times 2/3 to the x. I'm going to graph it.
And it decreases.
this time it's looking like that. 0, comma. I already knew this before my calculator.
Do we always have to put arrows on our amplifiers thing?
Yep, on your asymptotes.
No, not asymptotes on the graph.
Yes. Okay, here we go. X-intercepts. Where does it hit the x-axis? Doesn't. Both times. Doesn't matter. None. Y-intercept. It's 1. Y-intercept was 9. I knew that before graphing. Why did I know that? No multiplier, 1. Multiplier, 9. End behavior. So we're going from 2 to 1. Increasing. And here it looks like we're going from 2 to 1, but we're decreasing. Okay, and so before I graphed it, how did I know that that was going to increase and this was going to decrease? What told me? The base is bigger than 1 because it's 2.7, and here the base is 2/3, so it's less than 1, decrease. And then the domain is the same for both. So the forever domain. And again, the range is, the lowest height is restricted, 0, but not quite. Okay, so match this. So what do I know?
It's increasing.
It's increasing. So what does that tell me, first of all, about this equation?
Bigger than 3, 0, 1.
Base is bigger than 1. So it can't be A, because that base is a half. And it can't be D. Do you see that? Why I eliminated them? This has a base of a half, and this has a base of 3/4. And my y-intercept is at 2. So what do I know that gets me there? I need a coefficient in the front. So therefore it is B. See how I reasoned that? You know whether it's increasing or decreasing, and you know where your y-intercept is either 1 or something else.
Well, okay.
Okay, this one's a little bit tricky. You don't know this one quite yet. So let's just talk about this. Don't look at this for a second. What would you know about this graph? Is it increasing or decreasing? It's increasing. Is my y-intercept at 1 or somewhere else?
Somewhere. 1.
It's just at 1. Okay, so this is the y equals 2 of x to the x. It's increasing, it's your normal 1. Does anybody want to predict what this would do physically to some kind of graph?
Make it negative.
So I'm going to give you some options. Should I go left, right, up, or down?
Down.
Down. So can you picture this? And then just go boom, boom, down, down. Which one of them would it look like? 1, 2, 3, or 4?
3.
2.
What?
Just take this and move it down, down,
Oh, down to.
down. Just go boom, boom, down, down. It still looks like that shape. Do you see a shift down? So that's the only time you would have an x-intercept, is if there's something like that happening. Okay, so here we go. We were given an equation that models the price of a car. So the price of the car was 25,000 times 0.8 to the y, where price is the dollars of the car and y is the years. What does 25,000 represent in real life?
Money.
It represents the money, but of what particularly?
Car each year.
So let's think about this. Are we increasing or decreasing?
Increase.
We're decreasing. 0.8 is the base. Is that more or less than 1? Decreasing. FYI, your car is going to decrease in value every year, by the way, right? That you own it. And where's your y-intercept? Is it at 1 or somewhere else? Somewhere else. You have a multiplier.
Will our y-intercept always be the coefficient?
Yes, it's either 1 or, right? Like if there isn't anything in there, it's because it's a 1. So what does this represent? So we have years and we have the price of the car. So what can we say about the 25,000?
Years.
25,000 is the
Price.
price of what?
Car.
The car when?
Years.
When you bought it, at the start. Because it's at 0, so that's the start. So the starting price of the car. So on an explanation question like that, I can't just hear price, or you have to be particular. The price of what? What does 0.8 represent in this scenario? Okay, so this one's a little bit tricky. If you times something by 0.8, do you understand that that makes it go smaller? So your price of your car is, can I use the word depreciation? Have you ever heard that word, depreciate? Something gets less and less. Okay. Now, I don't depreciate my car by 80% of its value. Does anybody want to try to answer what my depreciation rate is? If I times it by 0.8, if I times something by 0.8, it's because I depreciated by 20%.
Oh my gosh, I was close.
Because what is a full value of something? What percent is full value? 100%. So if you go down 20, you are now going to be at 80% of your value, which is 0.8. Without graphing, putting it into your graph, what's the price of your car after 4 years? So you can just do this with basic math. 25,000 times 0.8 to the 4 years later. Isn't that sad? Your car is only worth that much. Kind of sucks, eh? Probably even less than that in real life. Okay, we're ready to try one more? Same kind of idea, ready? We have kind of the same. So tell me, is this increasing or decreasing?
Increasing.
Increasing, because
It's more than 1.
base 1.03 more than 1, we're increasing. Is my y-intercept at 1 or somewhere else? Somewhere else. 230,000. And we're having years and price. So as the years go on, our price increases. It's a house this time, so that makes sense. Houses appreciate. Appreciate, right? So what does the 230,000 represent in this example? Starting price of house. So that's what let's say you bought it for that. When you first lived in it, that's what you bought it for. What does 1.03 represent? Appreciation. So, what is full value of something again? 100%. So how much have I appreciated?
1, 10, 30.
3. How much am I over 100%? I'm 3% over. Do you see that? That's 1.03. So this 0.03 is 3% over the 100. So tell me how much your house is worth after 5 years. Without a calculator. Just try that. How's that? Your house got more expensive? Okay, and this is the last one. The number of bacteria in an experiment tripled every hour. So after 5 hours, we knew the population. So what's the population at the beginning? So I want you to make a T-chart. With hours and the population. And when you start an experiment, how would you start on hour number? How do you start something? 0. 1, 2, 3, 4, 5.
So divided by 3 each time?
Yes.
Oh my goodness.
Okay, so if I was tripling every hour, I tripled, then this would have been like the population times by 3, times by 3, times by 3, times by 3, right? So if I'm going to work backwards, you're going to have to divide by 3, okay? You can do it separately if you want, or you could use an exponent. How many times do you have to do this division? 1, 2, 3, 4, 5. 2,600, was anybody else getting that? Okay, essential math quiz here. What's your multiplier if you appreciate 20%?
2.2.
1.2. What if you depreciate 15%?
0.25.
So you're always the baseline at 100. You have to go down 15. What are you at? Close. What'd you do? 85. So your multiplier is 0.85. What if you appreciate by 5%? 1.05. What if you depreciate 5%? 0.95. We seeing this pattern? What if you appreciate 60%? 1.6. You got to be bigger than 1 because you're appreciating. You got to be bigger than 1. What if you depreciate 60%? 0.40. Got it? Got the roll of it now? This is very essential mathy. This is kind of what they would learn there. So use 100% is your base, right? And you either go up or down from 100%. 100% as a decimal is a 1. So you're either going above 1 or below 1 by that much, okay? So, and don't forget 2 decimal places, right? 2 decimal places when you move things.